All right, class, let's get started. We are doing 9.3. It's called Geometric Sequences and Series. So I'm going to video record this. So let's jam. So let's see, we're not going to do any homework questions here, just for you guys here. So Monday, we're going to do homework questions on 9.2 and 9.3. So please bring them on Monday. 9.2 is going to be due actually Wednesday of next week, because I do want to have one day to do homework stuff. So 9.2 and 9.3 will be due Wednesday of next week. So you guys have the extra day for homework. Anyways, let's get started here. So 9.2, last time we did was something called arithmetic sequences and series. So let's start off with that. Let's do the contrast here. So 9.2, all right, so 9.2 was the arithmetic. So let's do a little contrast here. Arithmetic. And what we found out in 9.2, hopefully you learned it, was the fact that arithmetic really just means add. Whenever we add stuff or add I think it was called a difference, wasn't it? Difference between the two. So let's do an arithmetic sequence from 9.2. So I got 3, I have 7, I got 11, 15, and I have 19, so on and so forth, blah, blah, blah. Let's go with it here. So if this was an arithmetic sequence, which it is, we should be able to add something, add a d value to go to the next level. So 3 plus 4 would get you the 7, and then 7 plus 4 gets you 11, and so on and so forth. Is that right? Add 4 here, add 4 there, and voila. Keeps on going. Arithmetic sequence. There it is. Awesome. Done. Okay, so now 9.3 comes along, and we have ourselves a geometric sequence or geometric series. What does that mean? It means multiply. That's what it means. Multiplying to get to the next level. That's the difference between the two terms here. So let's set up one here. So 2, 4, 8, 16, and 32, and so on. There it is. Again, if you don't copy it down, go for it. So in this case, in order to go from 2 to 4, we're going to multiply by 2. And notice what happens is it stays exactly the same. So 4 multiplied by 2 gives you 8. 8 multiplied by 2 gives you 16. 16 multiplied by 2 gives you 32, so on and so forth. There it is. That is a geometric sequence. Oh, and then really the difference between a sequence is that we have these individual numbers like 2, 4, 8, 16, 32. When we talk about series in mathematics, that means we're just adding these guys up. That's it. So series means you're adding the sequence together. Anyways, let's go to a proper definition before we go on here. So the DEF, the definition of a geometric sequence. All right, let's begin. So this is a geometric sequence, a 1, a 2, a 3, so on and so forth, all the way to AN. All right, if this is a geometric sequence, then there's a condition. So this geometric sequence such that this was what happens, is that A2 divided by A1. Whoa, looks like a little different here. Let's try this here. So A2 divided by A1 is going to give you an R value. The third sequence divided by the second sequence will give you the exact same R value. And you can keep on going. The fourth sequence divided by the third sequence will give you the same R value. So that's the proper definition. It's a little bit abstract, but let's do this here. Let's go back to the previous sequence that we just made. So 2, 4, 8, 16, 32. And notice what happens here. If I take the second term, which is at 4, divided by the first term, so there it is, that's A2 right there. That's A1 right there. Now if I divide the two pieces together, 4 divided by 2 is a 2. In fact, if I take any two terms like one term and the one right before it, that R value is going to be exactly the same. So let's do this. Let's do 8 divided by 4. Voila, 2. How about 16 divided by 8? Voila, 2 again. So we find out if you can set that up and consistently have that term be the same number, you have yourself the R value in this case, which is R equals 2. There it is. Okay, so let's start off easy. Let's start off exercise 1. Can you find the ratio R? And that's what R means. R means the ratio. What's the ratio that gets you one term divided by the term before it? All right, here's a sequence, all yours. So I'm going to go 5, I'm going to go 15, I'm going to go 45. So on and so forth, all yours. Give you a whole 28 seconds. Well, if you know this to be a geometric sequence, then you just take one term divided by the previous term, and you should get a R value. And if you're not sure, you can try a few others as well. But this one it is a geometric sequence. So 45 divided by 15, same R value, which is still 3. Done. R equals 3. All right, you guys try one by yourself. Go for it. So 12, 36, 108. Let's get some big numbers in here. 324. How about that? And so on and so forth is the sequence. All yours. Give you a whole 22 seconds now. Can you figure out the R value? So 36 divided by 12, 3. Hey, just like A. Okay. And then just take any other ones here. 108 divided by 36, and then that's still going to be a 3. Do that on calculator if you need to. And again, if you keep on going, all of them better be the exact same thing, or else it does not work. All right, let's go with it. R is equal to 3. Okay, let's do a little bit of a crazy one. Let you guys try this one by yourself first. Here is my sequence. A negative 1/3, positive 1/9, negative 1/27th, and a positive 1/20, positive 81st, 1/81st, and so on and so forth. So yes, I guess you could think of it. You can also think about, okay, what do I multiply negative 1/3 to give me a positive 1/9? What do I, so you can do this right here too. You can just kind of guess and kind of think to yourself, okay, what multiplies a 1/9? That'll give me a negative 1/27th. And if you can kind of guess that, and that still stays the same, that's perfect. I'm just going to go back to the definition of geometric sequences. And here it is. I'm going to take the second term divided by the first term. And I think what we do here, I'm pretty sure, is we keep the first fraction exactly, and this is a complex fraction. Keep the first fraction exactly the same. We change this to multiply, and then we take the reciprocal of the negative 1/3, makes a negative 3 ones, or a negative 3 over 1. And we got some reducing to do here. So how about 9 would reduce down to 3, negative 3 would reduce down to negative 1. And 1 times negative 1 is a negative 1. 1 times 3 is 3. Done. That is good to go. So negative 1/3 should be the ratio. If you wanted to check it out, if you're not quite sure if this was a geometric sequence, you just pick some other one here. So 1 over 81 divided by negative 1 over 27. And what is that ratio? And there is the ratio still a negative 1/3 or not? That's what we're trying to find out. All yours, go for it. Give you about 15 seconds. Try this yourself, go. See if you get a negative 1/3. All right, I'm going to go with it here. So 1 over 81, keep, change to multiplication, and then we're going to take the reciprocal. So negative 27 over 1. I'm thinking like by 9. I know 9 is going to go to 81, 9 goes into 27, so I'm going to do that. So 81 divided by 9 is 9. Negative 27 divided by 9 is negative 3. Oh, I could do this again. Notice 9 and 3 was still going to each other. So I'm going to reduce this guy by 3 and reduce this guy by 3. So how about a 3 on the bottom? How about a negative 1 on top? Multiplying the 1 and the negative 1 on top makes a negative 1, and 3 times 1 is 3. Still get the same thing. There it is. My R value for this sequence is a negative 1/3. Okay, last one of this type. I got a 1, 4, 9, 16, and dot, dot, dot. All yours. All right, and yes, I should give you a little bit of a disclaimer. So, and I'm going to say this may not be a geometric sequence. Just may not be. We'll see. So if we go second term divided by first term, we get ourselves a 4. We say third term divided by second term is a negative 9/4. Definitely, there it is. We're done at this point. If you want to try another one, 16 over 9 stays 16 over 9. That does not reduce. So can't get an R value because this is not a geometric sequence. That's it. That is it. Okay, so now let's start doing some stuff with this geometric sequence. So first things first is we're going to learn how to find the nth term of a geometric sequence. So let's do this here. Let's look at a sequence. Let's see if we can figure out the numbers, and let's see if we can actually put together a formula for this here. So I'm going to give you the sequence here. It is 3, 6, 12, 24, 48, and so on and so forth. So what we want to do is we want to come up with a generic a sub n equation for this. As you're staring at these numbers here, what's the formula for this? So let's talk about it. So first things first, is this a geometric sequence, yes or no? If I take the second term divided by the first term, gets me a 2. Let's see, fourth term divided by third term gets me a 2. Fifth term divided by fourth term gets me a 2. Yeah, and then we can also even do 12 divided by 6. That also gives you 2. So at this point, yes, we are assured that yes, this is a geometric sequence. But real quick here, notice what happens. The first term that we have is 3, is that right? But each time we need to get to the next number, we're going to multiply that number by 2. Because 3 times 2 gives you the 6. And then 6 times 2 gives you the 12. So let's see if we can put this together. Technically, the 3 is the first thing that's on here. And then what happens to get the 6, all we have is we have a 3 that's multiplied by 2. Everybody agreed? All right, with me still. Okay, how about this? To get the 12 really is 3 and with 2 2's, right? Or 4. So how about this? How about 2 to the second power, which is technically just 4, and 4 times 3 is 12. Let's keep on going because that's exactly what's happening here. So this one just adds another exponent to the 2. This is going to be 2 to the third power now. So let's see. 2 times 2 times 2 is 8. 8 times 3 is 24. Perfect. So this thing is really just going to go on. We're going to be putting in another 2 multiplier or just add an exponent. So we're kind of off a little bit here. Let me show you what we got here. We got this. Our first term, our a 1 is really just the 3 by itself. Our A2, and this is going to be A3, and that's going to be A4, right? This is the 4th term in the sequence. And that's going to be A5 because that's the 5th term of the sequence. So notice the connection between the A1, A2, A3, A4, A5, and the exponent that we got earlier. So we're always just 1 off. So if I take a look at that 5, really what happens is it connects to that exponent of 4. So that exponent is always 1 off. So 4 connects to 3. Yep, 1 off there. 1 off right there. And technically, this is really just 2 to the 1 power, right? How come we're off? Oh, yeah, because the first term does not have a multiplier of 2. That's why. So we're just off by 1 exponent. So let's see if we can put this together. This sequence, 3, 6, 12, 24, 48, has an initial value of 3 by itself. That's A1, right? And then what happens? It keeps on multiplying in 2s, but those 2s are kind of off by 1, right? So it's like n, you get to the nth one, you get to the 5th one, but you're going to say 5 minus 1. You get to the 4th one, but you're going to say 4 minus 1. Wait a minute. Hold on. Notice the 3 and the 2. Isn't the 2 our ratio? That's the R value, huh? So hold on. I'm going to do it like this. I'm going to say 3. This is technically 3 R to the n minus 1. Because that 2 is just our ratio that we multiply by each time. Hold on. And that 3, isn't that 3 just our first term? So really the generic equation here is this right here. First term times R to the n minus 1. I think I got it. Guys, this is it. What's the nth term of sequence? Here it is. A sub n. If you want the nth term of the sequence, all you do is you take the first term, multiply it times the R, or the ratio, to the n minus 1. So you could just be off by 1 term to get that. Cool. Let's jam with it. So now we can find the nth term of whatever sequence we like. That's so cool. Let's go for it here. Exercise 2 then. Exercise 2. So I need for you to find the nth term, of course, because that's what we're doing. Nth term of the sequence. And then find, let's go with, let's see, the 12th. Let's find the 12th term. So after you find the nth term, I'll let you try the the 12th term. So here is my sequence, 5, 15, 45. Seen this one before somewhere? Yep. Okay, so let's jam. Let's see. First of all, I need to find the ratio. So 15 divided by 5 is a 3. Done, right? If I just need to check it again just to make sure, if I'm not quite sure if this is a geometric form or not, 45 divided by 15 is still a 3. Yes, our R value is 3. I think that's all I need, because guess what? So A sub n is going to be, again, according to the formula, right? Formula is R, A sub 1, ratio n minus 1. That's our formula from the previous slide. Let's put it into context here. So the A sub 1 is technically the 5. That's the first term. Our ratio is 3, and we like to put it into parentheses. You'll see them always in parentheses. And this one's just going to be n minus 1. There it is. That is my formula. I have my formula to find any nth term I like. And what I want to do is I want to find the 12th term. So let's go with it. So A sub 12 of this particular sequence is 5 to the 3 of 12 minus 1, which is technically just 11. Right there. And if you guys can get out your calculators, unless you want to really multiply 3 times 3 times 3 times 3 times 3 times 3 times 3 11 times, that'd not be fun. In fact, just on your calculator, could you just do this? Just do 3 to the 11th power. I want to know what that is. We'll go from there. Load time, about 28.7 seconds. All right, time is up. Let's go with it here. So 3 to the 11th is 177,147, according to my calculator. Multiply by 5, then the 12th number in this sequence is 885,735. If you made it to that, you did great. All right, let's try one more. I'll let you guys try this one by yourself. Go for it here. Can you find the nth term? And then find the 15th term. Now this one's gonna be a little closer to what we normally do as applications. We'll kind of see an application problem here. So here's what I need. In fact, I'll even give it to you. So a sub 1 is 20. And your R value is 1.05. There it is. You have everything you need right there. All right, a sub n is a sub 1, 20. R value 1.05 taken to the nth minus 1. There it is. There's my formula all done. Okay. Now let's figure out the 15th term if you haven't done so already. So a of 15 makes 20 and makes this one 1.05 of 14, right? Because we're always off by 1. There it is. And see if you can punch that in directly into your calculator straight on through. So 20, put in parentheses if you want, 1.05, and then take that to the 14th power. And voila, if you did that, you should get 39.599. That's what the book sort of wants you to write down. If you wrote down 39.60, if you round off to the nearest tenth, that's totally fine as well. Okay, so before we move on to the next piece here, let me do this. This is kind of where is this found? Where is this found? So I'm going to jump to something called compound interest. So where is this geometric sequences found? It's found in compound interest. Let me give you the formula for it. And we'll jam with it here. So it says A, the amount that you have is the principal 1 plus R over N, N to the T. Whoa. So we'll do this one together here. So P is the principal. That's how much you are depositing into an account. R is the ratio, the rate, the interest rate that you're getting. N is a funny one. N is something called the number of compoundings per year. That's what you want there. And T is in terms of years. So let's do this here. I'm going to start off a problem here. So example 4. It says if you deposit $50 into a savings account that is earning actually 6% interest. And with savings accounts, what usually happens, personal savings accounts, they are something called compounded monthly, which means the bank gives you that money each and every single month. What usually happens, compounded. So it sits there for a month and they'll actually give you a little bit of percentage of the money that's sitting there. Okay, monthly. It's compounded monthly. You got to know how many times the bank's going to give you money. If it's a business account, Usually what happens is they give it to you quarterly. So every 3 months, they'll give you the interest on that money. Right? So the question is this, how much moolah will you have in 2 years? That's the question. So you deposit 50 bucks pretty much, and the bank says, hey, we give 6% compounded monthly on what you have in your savings account. Like, that's cool. So you leave it there for 2 years later. Let's see what happens, see what we've got. So let's do this here. I'm going to rewrite the formula again, and we're actually going to put in the numbers we need here. So compounded interest formula, Einstein actually said this is the 8th wonder of the world right here because of some interesting things that happen with compound interest. Anyways, let's go with it here. So for the previous problem here, I have P is equal to 50. That's the how much I'm putting into the account. The R value is going to be 6%, but we always write it as a decimal. So this is 0.06 coming in for the R value. And then N needs to be defined a little bit here. I'm going to put number of compoundings. That's the bank term that they give you interest at that time per year. So ours is monthly, is that right? Monthly. So that means the bank is going to give interest on the money 12 times during the year at the end of each month. Okay, and the time, how many years was it again? 2 years, absolutely. Okay. So let's plug this in. So A is equal to, I'm running out of room on the bottom here, so I'm going to do it on the top here. A is equal to 50. This is 1 plus, now R value is 0.06. Number of compoundings per year for this particular account is 12, and on top it's going to be 12 times 2. Okay, so a little bit of work real quick here to do. So 0.06 divided by 12 is actually going to be 0.005. So the 50 is in front. And all the stuff inside the parenthesis, let's simplify that. 0.06 divided by 12, then we're going to add 1 to it, gives us 1.005. Hey, very similar like the previous problem, huh? The previous problem was 1.05. This was 1.005. And 12 times 2 is 24. Okay, here it is. Can you punch this into a calculator? And can you give me the answer? That's what we're looking for. So 50 times 1.005 to the power of 24 gets me $36.36, looks like. I'm sorry, $56.36. That's not bad. In 2 years' time, we earned $6.36, and we didn't do nothing, just kind of kept it in the account, which is kind of fun. A whole bunch of stuff here. This is what retirement plans are built off of. These are something called annuities in general. These guys are all annuity stuff. How do you invest money in a certain portion that is guaranteed funds back or guaranteed a certain percentage? And we go from there. I used to teach a whole class just on finance formulas, which was really cool stuff. Okay, we're going to move on though. We've got 4 more slides left. We're going to go to the sum of a finite. So we're just going to handle finite here. I'm going to underline finite geometric sequence. Okay, so what this really means is series. So once you say the sum of sequences, you're saying series. So we're going to look at geometric series. Okay, I'm going to give you the formula for it because it takes a while to sort of set it up and build it up here. So here's our formula. So all those sequences that we just looked at, we're going to start adding them up. So we got that big sigma, capital S from the Greek letters. And here's what we do. We have our index. Index says we start off with 1, and we go all the way up to n. And it's going to be, look at that, it's a sub 1 again. It's the first term times the ratio of I minus 1. Notice it's not n just because our index is in terms of I. The question is this: if we were to add a geometric sequence together, the formula for it is a sub 1. It's 1 minus r to the n over 1 minus r. That's what it is right there. And we'll take a look at some stuff here. Okay, in this class, what we're going to learn is just to plug in the formula. Can you plug in the formula? Can you use it here? So example 5 says find the sum. Find the sum. Sum of what? Well, sum of I starting at 1 to 12 of 4. There's my a sub 1. 0.3 to the power of I minus 1. There it is. So notice the setup is exactly the same as our template, our formula. So let's jam. Let's put it in. So that means I'm going to write 4 because that's the first term. Ooh, and I'm going to go purple on me. Right here. This is cool. So 1 minus R value is in parentheses 0.3. And it's to the nth power. So that's 12. All over 1 minus 0.3. And close off the second parenthesis. There it is. All right. What we can do probably is just to simplify the denominator over there. So 1 minus 0.3. I'm going to rewrite it on the next slide here. It's just going to be 4, 1 minus 0.3 to the power of 12 over 1 minus 0.3 is just 0.7. That's kind of cool right there. So can you punch this into your calculator and get the answer? All right, I'll help you punch it into the calculator if you can't do it yet. So lots of parentheses here. And what we also need is we need a parenthesis to hold this numerator together as well. So we're actually going to have 2 parentheses when we set this problem up. Let me show you what I have on my calculator and we'll talk about it. Here's what I got. I got the 4. I got this big parenthesis that's coming in right here. Then I set up another parenthesis right here because I want to keep this numerator together. So I got a parenthesis for the numerator, 1 minus parentheses 0.3 to the 12th power. Notice I'm going to close off that numerator right there. Boom. Divided by, since this is a single term, it really does not need a parenthesis. You can just write 0.7. Then we're going to close off this parenthesis, and that matches up with this big parenthesis right here. Boom, click, and we get ourselves a 5.71. 714, however you want to write it, as long as you're close here. 5.714. Okay. All right, and one more. One more, example 6. Here's what we want to do. We want to use the summation notation. So given a whole bunch of numbers, can you find the notation for the sum, or the sum formula? That's what I wanted to see. Okay, so here it is. Here's what I got. 0.1 plus 0.4 plus 1.6 plus all the way up to 1.2 comma dot 4. I want you to set this up in terms of sum notation. All right, give you guys 20 seconds. Try it yourself. Go for it. You can look at your neighbor's paper. Won't be cheating. All right, and so let's see. Here's what I got here. Instead of thinking about it as a sum, what we've been working on is think about it as a sequence. So this is really 0.1, 0.4, 1.6, and so on and so forth, all the way up to that 102.4. Okay, but what we really want is we want a ratio out of this. So this is my first term. First term is 0.1. I already know that. What's my ratio? My ratio is the second term divided by the first term. That gets me a 4. Just to test it out, it'll be the third term divided by the second term. Punch that into your calculator, and you should get a 4. And voila, we got ourselves a geometric sequence with an R value of 4. And I think that's all I need. Let's check this out. Oh, maybe not. Let's see. So a sub 1 is 0.1. And the R value is 4. Oh, yes. We need to know how many terms we have here. So how many terms do we have until we get to 102.4? How does that work? Well, we know the formula so far, don't we? We know the formula is going to be 0.1 times 4 to the n minus 1. We know that for sure. So let's plug into our calculator. Let's do this here. I'm going to plug in this right quick here. So 0.1 times 0.1 times 4 to the 8th power. And if I punch this into the calculator, notice it's way too big. The 0.1 times 4 to the 6th power, that becomes 409.6. That's not it. But 0.1 times 4 to the 5th power, that gets me my answer. So that guy right over there is just 0.1 times 4 to the 5th power. All right, if that's the case, 0.1 times 4 to the n minus 1. What I just figured out is that n minus 1 piece is right on top. So n minus 1 really is 5. And if I were to add 1 to both sides, I get 6. So my n value is 6. That's what I need, because I need it for my formula. Here's my formula. It's going to be, oh, I can do this here. So a sub 6 is equal to 102.4. So let's put in terms of sum notation, and we'll be done. Here it is. Sum notation is, we have an I value starting at 1 and going up to, what do you guys say? 6. Absolutely. It's our highest n value we did. Our formula, 0.1 times 4 to the I minus 1, right? The I has to connect. There it is. I have used sum notation to write the sum in terms of a formula. All right, and then last 3 letters here, the end. And that is it. And I hope you guys have a great, wonderful day.